Okay, so mean is an average. How do you find, what's the mean of 2 and 10? 2 and 10. What's the mean of 2 and 10?
6.
What did you say, Nasia?
6.
Very good. How did Nasia get 6?
She added them together.
Add them up and divide by 2. Yeah. So that's what a mean is. Well, that's what an arithmetic mean is. Did you know there's different means out there? Because when you, she's like, oh, great. Really? So when you hear of mean, you probably think arithmetic mean. You add the numbers, you divide by 2. If there's 3 numbers, you add the numbers and divide by 3. If there's a million numbers, you add the numbers and divide by a million. Okay? So that's an arithmetic mean. But there are other means out there, and the one we're going to talk about today, imagine that, is called a geometric mean. Now, why would we need a different mean if we already have one? Let me just give you an example of when they use this in the real world, because you'll always wonder, when are people ever going to use this stuff? So, let's say we rated a company on a scale from 1 to 5 for how well they treat the environment with how they manufacture their products. Okay, so we rate the company A on a scale from 1 to 5, the company B on a scale from 1 to 5. And then we also rate the company on how well their employees like being there. But we rate the employees rate it on a scale of 1 to 50, how well they like being there. That's kind of a big scale. Anyways, so let's say company A got a score of 4 for the environment, but their employees weren't very happy, so they got a scale of, I don't know, 18, their employee happiness. And then this company got a score of 2, they're not very good to the environment, but their employees love being there, so they got a score of 48. Since we're using different scales, it would not make sense to just add these two numbers and divide by 2, right? 4 means something different than 18, because 18 is out of 50 and 4 is out of 5. So when you're trying to compare numbers that use different scales, that's when you would use a geometric mean. And you don't know what a geometric mean is yet, but I'm about to show you. So what is a geometric mean? You can write this in your notes right here. For any two positive numbers, A and B, the geometric mean of A and B is the positive number such that A over X equals X over B. And this will make more sense as we dive into it more. So we're at the very top. For any two, they've got to be positive. We don't do it with negative numbers. Positive numbers. Geometric, when you circle what you're writing, you're writing positive, geometric mean, positive. Anything else? And then you're writing this, of course, the most important part. So X is the geometric mean, and A and B are just the numbers. So remember, that company was rated what? They were rated 4 over X equals X over, and the other one I made up was what, 18? So that's how you would find, to find the arithmetic mean, you would add up 4 and 18 and divide by 2. To find the geometric mean, you would solve for X here. How would we solve for X in that proportion? Cross multiply, right? Okay, so what is 4 times 18 in your calculator? Ask him right now. What? 72. 72? What's X times X? Please don't say 2X. X squared. X times X is X squared. Oh my goodness. How do you solve that? Divide by 2? Wouldn't you what, Brett?
Square root.
Square root. Did you know the opposite of squaring something is square rooting it? Do y'all know how to find the square root on your calculator?
Yeah, so the square root is
Second and then the X squared. So it's going to be ugly. Oops, it's not going to be pretty. The square root of 72.
8.4852.
We'll take 8.5 because the 5 will tell the 4 to round up. So that's 8.5 would be the geometric mean between 4 and 18. Okay, let's move on. So here's an example. You have this one in your notes. Well, you just have a space to write it. Find the geometric mean of 4 and 9. So step 1, I already did step 1 for you. Write a proportion. So this is step 1. Put that under step 1 on your notes page. 4 is to X as X is to 9.
Is that
over time. Yep. 4 over x equals x over 9 in step 1. I know it's not very much room. You can write small, you can do it. Step 2. Cross multiply. You should get x squared equals 36, I hope. 4 times 9 is 36. X times x is not 2x. It's x squared. Final step. Take the square root of what? 36. Okay. Yeah. 6 is the geometric mean of 4 and 9. 6 is the geometric mean of 4 and 9. What's the arithmetic mean of 4 and 9? The algebra mean. Add them up and divide by 2. I'm curious, what is it compared to 6? 6.5? So they're pretty close. In this example, they're pretty close. The larger you get in your range away from your numbers, the larger the difference will be between the two means. All right, number 2. It's right next to it. You see it? Find the geometric mean of 10 and 40. Go. This is the easy part of the lesson. Okay, done. Kaylee, can you set up a proportion for me? Just tell me what to write. Equals what? No. Yeah, you knew it. Okay, there you go. So there's step 1. Julius, look alive. Julius, what's the next step? What do you get when you cross multiply? What? Did he say something? Okay, 400 equals x squared. Ooh, we got lucky. That's another perfect square. Catherine, what do you get when you take the square root of 400? 20. So the geometric mean between 10 and 40 is 20. Moving on. Okay, so that was the easy part, like I said, of the lesson. Now we're going to look at it in the context of triangles, okay? What kind of triangle, let me get my cards out. Ashley, what kind of triangle is ABC? Yes, that's exactly what I wanted you to say. ABC is a right triangle. So what we're going to learn today only works in right triangles. Okay. I'll take anyone on this one, but please raise your hand. What is segment BD called? It's from last semester. BD. It's called something. What?
Altitude.
Oh, they knew it. Altitude. Very good. BD is the altitude. Do you have this picture anywhere on your page that you could write this? Altitude? Could you write that anywhere? There you go. No, but it's BD. Okay, be careful. BD is the altitude. It's very important. So, this is only going to work when I have a right triangle and when I draw the altitude coming from the right angle. All right. In the big triangle, Dimitri, the big triangle, what is AB called? There's an L.
Leg.
Yes, very good. B, what did I ask you? BA? I hope I said BA. BA is the leg. Kendall, what's the other leg?
Yeah.
Nope. What's the other leg of the large triangle? What? Totally. BC. And Lewis M., what is AC called in the big triangle? There's an H. Yeah, hypotenuse. Very good. I know, isn't it?
Why didn't people just name it like God or something?
Well, because I think it was the Greeks who made it up. I mean, a guy named Pythagoras made up that. I mean, he had a weird name.
I know, but I mean, you can always name that normal because there's 2 legs and then.
So those words are normal and that word's not normal. Okay. What would we call AD?
Thing.
A segment, like a part of the hypotenuse, right? A section of the hypotenuse. Ashley actually has it right on. We are later going to call it a segment of the hypotenuse. And then DC would be another segment of the hypotenuse. Man, we wrote on that figure, sure, didn't we? Okay. Let's move on. All right. So if you've got a right triangle and if you draw the altitude, then you create 1, 2, 3 congruent triangles? Congruent triangles? Similar triangles. Thank you again, Ashley. 3 similar triangles. So I'll give you a moment to fill in the blanks on your notes.
So this is another separate thing?
Is this separate?
Is this-
No, you're right here.
I know,
The
but-
altitude. We're going to do that later. The altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original triangle and each other. 1, 2, 3. ABC is similar to ADB is similar to BDC. 3 similar triangles in one. It's like a nice little package. Who needs more time? Okay. Now we're going to learn 2 proportions. And the good news is, I'll give you these proportions on the test so you don't have to memorize the proportions. You'll just need to remember how to use them. So geometric mean is going to come back in here somewhere because you're like, why did I teach you geometric mean if we're not using it? All right, so if the triangles are similar, their corresponding sides are blank. Start with P. I've been doing this since day 1. Proportional. So if they're similar, then I'm just going to put pro because y'all know what that means. Then the sides are proportional. So that means we could set up a proportion. AD is to BD as BD is to... How'd you know?
From the paper.
Oh, it's already on the paper. That's no fun. Okay, DC.
You see, man, just that very similar.
Now, does this look familiar? As in, maybe this could have been A over X equals X over D. See how I repeated something like we did with the X? That means BD is the geometric mean between AD and DC. BD is the geometric mean between AD and DC. What is BD in the triangle? Is it a leg? Is it a hypotenuse? It's the altitude. So an altitude is the geometric mean between, what's AD? Segment. And what's DC? The other segment of the hypotenuse. So the altitude is the geometric mean between the segment and the segment. And that's what we're going to write down. Not there, but there. I need you to write this proportion down. I would write it like right under this theorem, like under this proportion right here. Like draw an arrow like I did, like instead of this, write this, because this will help you right here. The long segment over the altitude equals the altitude over the short segment. Whew, that's a lot of words. The long segment over the altitude equals the altitude over the short segment.
Oh, see, I don't know.
And honestly, you can switch up those 2 segments. It doesn't have to be long first and then short and then long. But the important thing is that you use the altitude twice because the altitude is the geometric mean. Okay, let's try one. And once we try it, you'll be like, oh, that's easier than she was making it sound. You really will. Unless your head's down and you're not listening. All right, solve for X. The altitude is the geometric mean. So that's the one you write twice. And then 2 and 8, I don't care where you put them. So set up a proportion. Megan, you got one?
What?
You got a proportion yet?
Yeah.
Okay, I'm ready.
X over 2 equals 8 over X.
Okay, that's going to get you the same result. But I'm going to be consistent with the proportion that I gave you. So we said long over the altitude equals the altitude over the short. So I'm going to do the long segment. I'm going to do 8 over X equals X over 2. But yours is going to get the same answer, Megan, so that was not wrong. I just want to be consistent every time so I don't confuse people. All right, cross multiply. Brett, 8 times 2.
16.
X times X.
X squared.
Yeah. Nasia, X equals?
4.
Yay! So the geometric mean between 2 and 8 is 4. Moving on. Try this one by yourself without me leading you. Go. Long segment over the altitude equals altitude over the short segment. Omar, can you tell me your proportion?
18 over X.
Yep.
equals X over.
Perfect. Liz, are you awake? Are you awake? You don't want to miss it. It's a new lesson. Shelby's not here. Torin, what do you get when you cross multiply?
Oh, a 72.
Oh, did we already do this one?
Yeah.
This was the one I made up. I didn't even realize I was doing this example when we made this up. Okay, we already did this. X equals, what's the decimal approximation?
8.5.
Cool. That's nice. Okay, I only have one more thing to teach you. Do we have time? Do we have time? Yes, we do. That's gibberish, so I'm going to skip it. This is what you need. This is your other proportion. There's only two proportions. This is your other proportion.
What's going back?
On the back, on the back, on the back, on the back. You were probably thinking, well, what if I'm not looking for the altitude? What if I'm looking for another part of the triangle? Then what proportion do I use? You can use this one, and this one doesn't make a lot of sense yet.
So would you still use the same because AB is X, so like it's the same.
Yeah, it's the same, but it's using different pieces this time. Yes, but
That
adjacent side, very good. Kendall's like, what's ADJ stand for? It does stand for adjacent. Adjacent means next to. So let me show you what's going on. It's when you're looking for AB. That's a leg. You're looking for AB. What you do is you put the hypotenuse. Which one's the hypotenuse? Very good. You put the whole hypotenuse over the leg equals the leg over the adjacent segment. Which segment, AD or DC, do you think is the adjacent segment to that leg? AD. It's the one closest to it. Closest to it. So let's try one. You wrote down the proportion. Let's do it together. Hi. So the hypotenuse, how long is the, oh, she's on here. How long is the hypotenuse? Because that's what it says to grab first.
18.
You have to add them together. 18. 18 is the hypotenuse. Write it down. 18. Over X, it's always X, equals X over, which one is closer to X?
8.
8, not 10. 8. 8, 8, 8, 8, 8. So you put the hypotenuse here, you put the closer one here. And then you know what to do now. Cross multiply. Tell me what you get when you're ready, Matt. Okay, x squared equals 144. Yay, a perfect square.
Whoa.
Square root of 144, anybody? 12. Nice, pretty answer. Okay? This one we have to draw our own picture, and then we will be done for the day, I promise. The altitude to the hypotenuse of a right triangle, well, let's go ahead and draw ourselves a right triangle. Since most of the time they've been drawing it like this, let's just draw it like this, because that's how all of them have been. So draw like an upside down right triangle, and then draw yourself your own, that was weird, sorry, hypotenuse. Not hypotenuse, the altitude. Whew. Divides the hypotenuse into segments of 3 and 27. So I'm going to put 3 and 27. Find the length of the altitude. Where do I put x? Over there. Where's the altitude? It is the altitude, so it's that one. It's not the leg, it's not the leg, it's the altitude. Oh, this one's the easy one. Remember this one? This is the first one you learned. So you use the first proportion. You're looking for an altitude, so use the proportion that has the word altitude in it. Jeanette, tell me what to write. You know it's something over x equals x over something. Yeah? That's all there is to it. 3 over x equals x over 27. Cross multiply. Austin, what do you get? What? Oh, another perfect square. Yay! Square root of 81. 9. Lesson is over. We're not going to do the last example because we don't have time. Keep those notes because I'm not going to give you a worksheet over this. So hold on to those notes. You're going to need to look at them before the test because you're not doing a worksheet on this. Tomorrow we'll have an assessment where I will assign your partners. I will assign it, not Chance. Chance won't assign it. And then Monday there's no school. Tuesday we review, and Wednesday we take our first test. Please put everything away. Calculators, markers,